Welcome to this lecture on standards for safety and security. My name is Christoph Ebert and I'm responsible for the consulting activities in Vector. Within this presentation, I will outline current evolution paths with standard on safety and security. Let us start with a very simplistic view to the standards, and I found this Dilbert, which speaks about the quality and priorities. And they said quality is a top priority, and then his staff was asking, is it safety important? Of course, safety is important. Is it more important than obeying the law? No, of course not. Shall we maximize shareholder value? Well, of course we should. But how do they contrast these different factors with quality? So at the end, what we realize with this very simple cartoon is that quality cannot be a set of priorities. It's a habit. And that means also in terms of standards, we have to follow the standards, but we also have to understand what is the best way to follow these standards. I will explain you what it means. Let us start with functional safety, because functional safety is clearly the major topic which we face in any of our activities. It's about to protect health of the people. And we have in automotive one very popular safety standard, which is the ISO 26262. The underlying methods such as HARA, which is a hazard analysis, a fault tree analysis, a failure mode analysis, or the concepts to achieve safety like fail operational, or redundancy, all these are confined in the ISO 26262. But it's also clear safety cannot work in itself. If a safety goal can be compromised by a hacker, then we have a problem because the safety goal is not anymore valid. So that means cybersecurity is a condition to achieve functional safety. Also here we have standards like the ISO 21434. And we have underlying methods like a threat analysis, defensive coding, cryptography, key management. And we see sometimes even as an overlap, both are risk-oriented. The HARA and the TARA have a lot of similarities. Now, cybersecurity needs privacy. We have a lot of underlying standards which govern the whole set of security, which is the ISO 27001 and the related standards. Again, here we have a set of underlying methods. And what we can see in this very simple picture is all these factors depend on each other. And it means we cannot simply say, let's work for safety. What we have to tell is, let's use a holistic systems engineering in order to achieve quality. This is why I said earlier, quality is a habit. It's not a set of priorities. The whole building of the different standards is what we call product liability. Product liability means that if we bring a product into service, it has to provide a level of safety which can be expected by the general public. So it's obviously safety oriented, but it means, of course, also product liability from a set of requirements with reliability and others also has to fulfill these demands. So in functional safety, the mother of all standards, that's the IEC 61508, which is many decades in use and from which the 26262 had been derived. Today we have the ISO 26262 edition 2, which refers to shared methods, which refers to different approaches, which we can also use in other standards. Also, we have recently some evolution with respect to autonomous vehicles like the 21448 SOTIF standard. Then, on the other side, we have the cybersecurity. Here, a classic standard is the SAE 3061 and more recently the ISO 21434. But we also have standards with respect to enterprise IT security like the before mentioned 27001, TISAX, which is the Trusted Information Security Exchange, and many more. All these different standards are used to achieve homologation of the vehicle. Finally, they build upon underlying quality management and process management. We use the ISO 33001 for assessments. This is what we call Automotive SPICE or CMMI. These frameworks help to establish a good underlying process framework, which in turn is based upon our quality management system, which is the ISO 9001 or the ISO 16949. So we see it's a building where different pieces build upon each other. Let's zoom a little bit into some of the mentioned standards. The 21434 on automotive cybersecurity has a very clear structure on which we can see what I just explained with respect to this overlap in terms of different shared activities. We have, for instance, on one side, the cybersecurity management. We have project-dependent security management, and we have a lot of activities which are used throughout the life cycle. In other words, the standard very clearly covers the life cycle, but also points into how do we achieve cybersecurity from a culture perspective. And this is a big lesson learned from functional safety, because also here we need a safety culture. So a couple of these organizational topics clearly overlap between the different standards. And this is something which is quite relevant, because a standard is not only a technical set of methods. On the opposite, typically a standard would not prescribe any specific method. It gives a guidance in terms of how do we set up goals, how do we achieve the specific underlying quality objective. That means not a technology nor a solution is prescribed. It's the way how we have to work throughout the life cycle to deliver a product which follows the cybersecurity requirements. Now, a question which we often get from our consulting project is, how is this related to type approval? Type approval is a set of different standards which have been built over the past decades. And if you look to this picture on the right, you can easily see there is a huge amount of such underlying governance standards, like I marked one, which the R48. This is the headlight control, which gives us some guidance how headlights have to be dimensioned, how they have to be controlled. And we see many, many more, which I'm not going to read one by one, but it basically covers the whole vehicle with respect to its impact on environment, of course, theft protection, functional safety, availability, connectivity, or information sharing. I marked two areas because this is what we talk in this presentation: safety on the one side and security on the other side, because that is something where we can clearly see how it is going to be implemented. Let us look into what the UNECE tells about these type approval related activities. A very recent evolution is from the working group 29, which has suggested two standards to be used. One, which is here on the left side, which is about cybersecurity. Another one, which is about software update management. The cybersecurity aligns pretty much with the ISO 21434 in terms of life cycle coverage, in terms of threat analysis, which is a risk-oriented cybersecurity, and in terms of the preparation to ensure also that security is ensured along the life cycle. We also have on the other side software update management. Why? It's clear that we have increasingly amount of software which comes directly to the vehicle, which is either adaptive or which learns from situation, or which is just updates. It's like a patch, like a functional enhancement. All these updates have to ensure that we will not violate the previous type approval. So the software update management from UNECE perspective is a regulation which certifies the OEM in order that any software update still pertains to ensuring that the previous type approval is not in any way negatively impacted by any of the type approval parameters. What would it mean? We have seen before the R48, which relates to the headlight. Now, modern headlights have a multi-ECU coverage. It's not only just an on-off. This is dynamic regulation of the headlight, for instance, with respect to the environment, with respect to cars which would come across the street, etc. That means the R48 governs how this headlight control would be done. Now we do a software upgrade. The software upgrade might impact an ECU, and suddenly maybe the headlight could not anymore be blinded down if there is a vehicle approaching us. Now obviously this is a safety risk. This is something which is governed by R48. So this software update cannot be delivered because it's a violation to a type approval parameter. That's the idea behind this UNECE software update management, which we currently introduce, starting with the OEMs, but then also with the different suppliers, in order to ensure that any software update both ensures cybersecurity requirements as well as the underlying safety and other regulations which are necessary for type approval. And that also explains why UNECE demands that there is a certification process behind, because not only manipulation could happen by outside attackers, but there can be also software glitches which can manifest into a severe safety risk. And for that reason, the way how a software update is developed, how it is distributed, this has to be governed carefully. That's exactly content of this recent UNECE regulation of the Working Group 29. Having said all that and getting back into our previous cartoon where I said quality should be a holistic activity, it should not be a set of priorities, our vector recommendation is very clear-cut. We should combine the different processes with respect to safety, with respect to security. Makes not much sense to keep these processes separate, because what we have seen in many situations is that often we have a situation where we have ivory towers which would govern security, another one which is a safety manager, but the big benefit is in combining the two. Why? Because any safety goal which can be compromised, as I said earlier, by a security attack is of course then not anymore ensuring functional safety. So we have to ensure from a cybersecurity perspective that our safety goals cannot be compromised. And that is why the best approach is to start from the top in the life cycle, always connecting the safety and the security activities. In fact, process management such as ASPICE already considers this overlap, and this is what we show on the right side in this picture, which shows, for instance, that we have this overlap between safety as a standard, between security, but also the underlying process framework, which, for instance, we govern by means of ASPICE. So the real target, both from a perspective of achieving quality, but also cost efficiency, is to orchestrate these different process elements in order to achieve a maximum benefit from the different process without overhead. And in a practical situation, we can see that we typically recommend that with the project start, we have a couple of synchronization points, as we show here on the left side. For instance, you do an initial systems analysis with respect to what are the risks. That means we have a HARA from a safety perspective and a TARA from a security perspective, which we then align and see what would be the different risks, how do we prioritize the risk. Then we achieve a safety goal, and we have again a synchronization point, which is, can this safety goal be compromised by a security attack? That would be the next synchronization point. Then we have a safety concept, and the safety concept has to relate to the security concept. And on we go throughout the life cycle. Even when we talk about testing, a pen test from a security perspective should first and above all ensure that we cannot harm a safety goal by any way of external manipulation. That means we have a lot of these synchronization points along the life cycle, not the least, of course, when we talk about the software update management, which I just explained with UNECE WP29. In a more detailed perspective, we have a synchronization which aligns with the risk analysis, which is that we look into assets to protect. Then we look into, can these assets be impacted by safety hazard? And if so, what would be the respective way? This is what we call the safety goal and the safe state in the safety analysis. And then we go back again to the security track and see, is this something which we can compromise? And so from left to right, we achieve an evolution path which ensures that our different measures with respect to systems engineering and architecture achieve a stepwise evolution to make our system more and more robust, to have an architecture which guarantees functional safety and cybersecurity. This is an experience which we have achieved a lot of benefit in our different consulting projects. Let me summarize with some practical aspects from our consulting projects in the recent path. And I would start with the OEM perspective, where we clearly recommend to establish a system-wide safety and security responsibility. Don't disconnect. Don't have here a safety manager, here a security manager. Try that they work very close together. Connect the requirements. As I just explained, starting with the safety goals, how can they be compromised or to have these synchronization points? Align your EE organization with the IT organization, because increasingly with the update management or key management from a security perspective, we need to have aligned organization. Communicate a security strategy not only internally but also to your suppliers. Your suppliers need to know how this cooperates. And finally, from a perspective of OEM, ensure, of course, that your contractors, your suppliers, observe the necessary standards, laws, and legal provision that must be recorded, that must be traceable. Now, if we switch positions and we look towards supplier, then it's obvious that a supplier needs context information. This is not something we can do in isolation. Security out of context makes no sense. Security is a system perspective and needs inputs from an OEM. For the same reason, we need to have supplier OEM development interface agreement. This DIA was already proposed in the ISO 26262, but it makes a lot of sense also from a security perspective. Again, we do not recommend any sort of diversity between these two standards. Try as much as possible from a process perspective to balance both sides. And finally, perform periodic workshops between supplier and OEM to test assumptions. It's clear that the OEM can and will not disclose all the underlying security mechanisms, especially if there are different suppliers. But on the other side, since we have to take assumptions, it's also clear that we have to harden our subsystem based on valid assumptions. And this is exactly what we recommend in these workshops. With this being said, we can conclude what I said in my introduction, that product liability holds for all the products along the supply chain. It's not something where we can simply say, it's the one who brings the product in the market. I mean, there's a supply chain behind. And the supply chain is governed by product liability. Product liability means that we practice the state of the art. The state of the art is the standards which are released at the time when we design the product, when we develop the product. And this is currently our functional safety standards like the ISO 26262. It's the cybersecurity standards like the 21434. It's a type approval regulation like UNECE, Working Group 29, specifically with the cybersecurity and the software update management system. And these different in combination can typically only be achieved by a solid process framework, such as what we achieve with ASPICE Level 2. And that means this is exactly what we call this holistic connection of the different standards which should be applied. I appreciate your listening to this short presentation on the current standard evolution. And of course, there are certainly much more questions to be asked. So what I recommend is that if there are questions, you contact us at www.vector.com/consulting. Thank you and good success with functional safety and cybersecurity and the application of standards in order to improve your product liability and your responsibility for good quality without any priority conflict. Thank you.